Hey guys, welcome back to Battery Hacker. In this video, I am going to break down something people constantly ask. How many batteries do you actually need for a 5 kilowatt solar system? Here is the quick spoiler. For a system like this, you are looking at roughly 15 kilowatt hours of lithium battery storage. Now, let me walk you through exactly how that number is calculated step by step. Imagine you are running an off-grid cabin powered by a 5 kilowatt solar panel array. And let's say this cabin is located in Washington, D.C. This chart you're seeing is based on the PVWatts database, which shows the average sunlight hours per day throughout the year. To size a system properly, we always use the worst-case sunlight, which is the winter season. So for Washington, D.C., we'll use an average of 3 sunlight hours in winter. With 5 kilowatts of solar panels and 3 sunlight hours, the system can generate around 5 kilowatts times 3 hours equals 15 kilowatt hours of energy per day. And here's the key rule. Your solar panels must be able to recharge your entire battery bank in a single average winter day. So if the panels can produce 15 kilowatt hours a day, your battery bank must be able to store at least that much. That means we need a 15 kilowatt hour lithium battery bank, which usually equals about 3 48-volt server rack batteries. If you're using lead-acid batteries, you have to double the capacity, because those batteries should only be discharged to about 50%. So instead of 15 kilowatt hours, you would need 30 kilowatt hours of lead-acid storage. This is still a simplified explanation. We aren't adding losses or inefficiencies yet, but it already gives you a very solid idea of how many batteries a 5 kilowatt solar system really needs. Now there is something important you need to understand. The question, how many batteries for a 5 kilowatt solar system, is actually the wrong way around. You do not choose your battery size based on the number of solar panels. Let me show you how it truly works. The correct method starts with a load analysis, meaning you first calculate how much energy your home actually consumes in a day. After that, you size your battery bank, usually based on 3 days of autonomy for cloudy or stormy weather. Then finally, you size the solar panel array based on how much energy the batteries need to be recharged in one day. Let me explain with a simple example. Here is a small list of home appliances and how long they run each day. By multiplying the power rating of each appliance with its daily runtime and then adding them all together, we find that the total daily energy consumption of this off-grid home is 10 kilowatt hours per day. Now we apply the 3-day autonomy rule. We multiply 10 kilowatt hours times 3 days, which gives 30 kilowatt hours of battery storage. To store that amount using lithium, you would need about 6 server rack batteries, and the total cost would be roughly $7,000. Now we size the solar panels based on the battery bank. The batteries must be fully recharged in a single day. If we assume an average of 3 sunlight hours, then 30 kilowatt hours divided by 3 hours equals 10 kilowatts of solar panels. So the properly sized solar array for this battery bank would be 10 kilowatts, or 10,000 watts of solar panels. That is the correct order of designing an off-grid power system. Load first, then battery, then solar panels. All right, let's return to the original question where we calculated that a 5 kilowatt solar panel system would need around 15 kilowatt hours of lithium battery storage. Now, let's flip that around and ask something even more important. With a 15 kilowatt hour battery bank, how much energy can you safely use each day while still maintaining 3 days of autonomy? Take a moment and think about it. Here's the answer. You can only use about 5 kilowatt hours per day. Why? Because the battery bank must hold enough energy for 3 full days of cloudy weather. So we divide. 15 kilowatt hours divided by 3 days equals 5 kilowatt hours per day. That means if you want true 3-day autonomy, your daily usage must stay around 5 kilowatt-hours. If this video helped you understand solar sizing in a clearer way, feel free to like the video or subscribe to Battery Hacker for more practical solar breakdowns. Got a question? Drop it in the comments, and I'll try to help you out. Thanks for watching, and I'll see you in the next one.